Okay, we are back. We're going to talk about repetition structures and a little bit about arrays. So, what is a repetition structure? Well, if you dissect it with English, it's something that repeats, right? Some structure that repeats. If you were playing a video game and every fight was cut or dried, you had a 50% chance to win, a 50% chance to lose, and that was it. You wouldn't play the game very long, would you? What a repetition structure allows us to do is go away from, the one sword blow kind of thing to being able to repeat the combat sequence in a video game. Or if you're inputting grades into your grade book as a teacher, you may have the ability to enter more than one grade over and over and over again until it's time to stop. So that's kind of what's behind the repetition structure thing. It allows us to repeat actions inside of our code, or even to repeat our whole program. So the number of times that we can do this is controlled by the programmer. It can be controlled by the program itself, or the user can set up and say, I want to do this 25 billion times, or whatever they choose to do. 25 billion times they'd be entering yes, no, or something for the Casablanca movie a long time. We're going to talk about two main repetition control structures in Perl. We're going to talk about the while loop and the for loop. And both of those can handle the two types of repetition that we have, counter-controlled and sentinel-controlled. Counter-controlled is just like what it sounds like. You determine the number of times it's going to go through a loop, and once it hits the end of that limit, it stops. It breaks out and goes on to other code. Sentinel-controlled, imagine a bagpiper on the walkways up there on the top of a castle looking out to see if any enemies are coming. That lone sentinel, that lone piper on the battlements, when he sees, a force of enemy warriors or enemy ships coming up across the lock, what he will do then is start playing the bagpipes as a warning to the rest of the castle that the enemy is approaching. That's what we mean by a sentinel. And that's also what we use in sentinel controlled repetition. We set up something that is outside of the normal circumstance. And then if that shows up, that becomes a cue, or a clue rather, that we should get out of the loop and go on to whatever code follows. Both types of looping structures can be used for both types of repetition. But generally, we use the for loop for counter-controlled repetition because it's kind of built that way. And counter-controlled is known as definite or finite looping. We have a direct end that we know is going to happen 15 times from now, for example. Sentinel control is when we use it for, we don't know ahead of time what the end of the thing is going to be. If you're fighting that boss monster, you don't know if it's the second blow that is going to kill it or the 200th blow. But when it hits the flag that says boss monster dead, it breaks out of the loop and goes on and does other things for your character. Again, sentinel controlled looping can be done with either the for or the while, but you will mostly find that like for loops are associated with counter control, that the while loop is generally associated with the sentinel control. Sentinel control is known as indefinite looping. And if you get a program that just keeps scrolling and never ends, that's generally called an infinite loop, and that's a pain. What you can do if you're stuck in an infinite loop is hit the control key and the C key. That will break you out of any program that you're running. Control C is your friend. And that's from the old days. Now, both counter-controlled and sentinel-controlled repetition have basically 4 requirements in order to create a good loop. Whoops, wrong thing there. You'll need the name of an LCV, a loop control variable. to store either the counter or the sentinel value. You'll need an initial value of that LCD. So if you wanted to count to 15, you'd probably start with 0 and go to 15. You need a modification each time it goes through the loop. So if you wanted to increment by 1 each time, you could just do variable plus plus. And if your variable was originally 0, it would become 1, and then 2, and then 3, adding 1 to it each time it goes through the loop. And then finally, the fourth thing that you need is a condition. And that condition will see whether or not the exit condition has been made, or has been met, I should say. Whether it's the limit of 15, or whether you've actually thrown, say, a -1 into a program as a sentinel. Here's a while loop. This is back to almost basically what we saw in an if statement. So while some condition, we do whatever's in the body. Now, we're going to talk about condition here in a minute, but notice that third bullet point. While loops are continued pre-test loops, which means you have to meet a certain condition before you go into the body of the loop. If the condition is false before you ever get to it, it might mean that you never go into the while loop at all. And that can happen. So here's a simple while loop. We've got our, well, let's go over here where we've got the color highlighted. So let's vim PCC, whoops, one too many C's. So my $start is equal to 1. There's assigned the value of 1, I should say. See, I told you guys, even I do it once in a while. So here's our loop. While in the condition, $start is less than or equal to 15, then we've got our curly braces here, and I'm going to move this down again because I prefer GNU. Inside of the curly braces, the code we say, code we do is say counting : $start. Notice we're interpolating this. It's double quotes. So what's going to happen is counting $start, which means the first time we come through, it's going to be counting : 1, then 2, then 3, then 4 as we go through each repetition. What does start plus plus do there? Scan the video back about 5 minutes and you'll hear me tell you what it does. Start plus plus, the plus plus says increment me by 1. So we come in here, say counting 1, 1 plus 1 is 2. We put 2 back in $start, 2 is less than or equal to 15. Counting : 2, 2 plus 1 is 3. And we repeat until we hit 15. Now, the last value outside of that loop is $start. So let's see what this does first, and then we'll talk about that last line of code. So we're going to Perl PCC. Whoops, I added a PL there. So this is what we're doing. We're counting from 1 to 15. But notice the last value. The last value is 16. So let's go back into the code. And let's figure out why. So we go from 1 to 14. So we'll say counting 14, 14 plus, or start plus plus gives me 14 plus 1. We go up, 14 is, 15 rather, is what it becomes. 14 plus 1 is 15. 15 is less than or equal to 15. So we're going to say counting : 15. 15 plus plus says 15 plus 1 is 16. $start is 16. 16 is not less than or equal to 15. So we're through with the loop. We go down below the closing curly brace and we print out that last piece of code. And that last piece of code here says the last value is $start. And we just showed that $start, in order to break out of that while loop, was going to be 16. So that's why when we run the thing, our last value is 16. This, the 15, 14, 13, etc. that we saw on the screen above the 16, just gives us What's inside the loop? The 16 is the number that breaks out of the loop and says, we're done. So let's go on to the next one. Oh, for crying out loud, never mind. So first of all, we did start less than or equal to 15. We counted up, right? Well, notice the difference here. Let's grab a little more, make a little more light on the subject here. So 1 through 3, we've seen that happen all before, but notice that line 3 up here says my dollar start is assigned a value of 1. Here it says my dollar start is assigned the value of 15. While dollar start is greater than or equal to 1, say counting colon start. So in this case, we'd have 15. Anybody remember what minus minus does? This plus plus is called an auto increment, right? This though, minus minus, is called an auto decrement. So instead of adding 1, we're subtracting 1. So we start out at 15. 15 is greater than or equal to 1, counting colon 15. And then we do 15 minus 1, which gives us 14. We go through and go through and go through. We finally get down to where start is 1. 1 is greater than or equal to 1. We say counting colon 1, start minus minus, 1 minus 1 is 0. We go back up. 0 is not greater than or equal to 1. So we skip the rest of the stuff in here for that last run. And then we print the value, or the last value is dollar start. Dollar start in this case would be 0. So let's see it run. Let's make sure that I'm right. Whoops, wrong one. This is the one we need. So let's Perl PCC1. I keep doing an extra PCC. So we start at 15, we go down to 1. Again, 1 is greater than or equal to 1. We go into the loop. We state counting colon 1, and then 1 minus 1 is 0. And that's how the last value is 0. It fails the last test. 0 is not greater than or equal to 1, so it breaks out of the loop, and then it gives us the last value of dollar start. So let's take a look at the next version here. Remember the compound assignment operators? So we're going to do this as a decrement again, but we're not using auto decrement. Instead, we're going to start at 15. While start is greater than or equal to 1, counting start, start minus equal 2. So if we start at 15, and then we take 2 away from it, what are we going to get on the screen the next time? If you said 13, you're right. So 15 minus equal 2 after the first run gives me 13 in start. 13 is greater than or equal to 1, et cetera, et cetera, et cetera. The last one we're going to have is a 1. So start is 1. 1 is greater than or equal to 1. We say counting 1. And then 1 minus equals 2 gives us what? Not a 0 this time. We're taking 2 away from a 1, so we get to a minus 1, a negative 1. And that's what's going to print out on line 9. So let's make sure it happens that way. So we're going to Perl PCC3, nope, 2.pl. There we go. We're counting down by 2 from 15 to a negative or a 1. And then our last value in start is a minus 1, because minus 1 is not greater than or equal to 1. So we break out of the loop. And the last value is the value that we use to break out of the loop, in this case, the minus 1. So let's go back. I think we've got one more of these we want to do. And this is slightly different. Now, we're counting from 1 to, basically, this is the same piece of code as the first one we did, where we were incrementing every time we go through the loop. But the difference is line 4 and line 3, if you think about it. How many times should we loop? Chomp, my dollar num is the diamond operator, which means our user gets to choose how many times we go through. My dollar start is 1. My dollar start is less than or equal to num. Remember that the program is not going to be looking at it as num. It's going to be looking at it as whatever our user put in as their number. So counting colon dollar start, we'll put in whatever start is. In this case, it's a 1. So counting colon 1, start plus plus means 1 plus 1 is 2. We go through. 2 is less than or equal to dollar number, as long as they didn't put a negative number there or something. And at the end of things, we're going to put the last value as dollar start. So let's check this out again. So we're going to Perl pcc3.pl. How many times should we loop? Let's say 3. 1, 2, and 3 is what we counted out to the screen. 4 was the next value of start, which broke us out of the loop and let us have the very next line of code, in which case the one that states the value of start is 4. How long does it take you to count to 1,000,000? Anybody know? Well, for human beings, if you started when you were when you first started to learn about numbers and counted 1 number a second, it's going to be a hell of a long time. Let's see how long it takes a computer to do it. I think we were about 20 or 25 seconds there. Usually when I do this on a larger computer, I'm working on a laptop today, an old laptop, let's put it that way. Get about 10 seconds. In this case, in 25 seconds, that very, very simple few lines of code gives us the ability in about 20, 25 seconds to count all the way up to 1,000,000. Please notice that no matter how large our number was, it's the same bloody thing. Our last number is the limit that our user put in, 1,000,000, but the last value, once we break out of the counting loop, is 1,000,001. So no matter how big the numbers are or how small they are, if you're going in a negative direction, doesn't matter. The code performs the same way. I suppose you could put ridiculously large numbers in there and break the thing, but that's really not what we're trying to do here. So you won't be a hacker if you break our little tiny programs. Now, let's try using something like this in something that might be a little bit useful. So this is a gradebook program. And notice that user bin Perl, use modern Perl. We talked about declaring multiple variables at the same time. Now, the cool thing is, if you're declaring multiple variables, you can also initialize them. This is called a list. It's kind of one step away from an array, and we'll talk about those here in a bit. So the way this works is that they're done respective to the variables on the left-hand side of the assignment operator. So total is 0, counter is 1, grade is 0, average is 0. If that confuses you, or if you don't like doing it that way, that's perfectly fine. You can declare your variables separately and initialize them separately if that's what you want to do. Now, here we're going to have a hard limit in our grade book of 5 students. It must be a Montessori school or something, right? We have a very, very small student size, or student body. So while dollar counter is less than or equal to 5, we're going to enter, or print out to the screen rather, please enter grade dollar counter. Now, what does that please enter grade dollar counter do? Well, obviously it is interpolated. It's got double quotation marks on it. What does dollar counter equal the first time we go through? It equals a 1, right? Because that's what we initialized it to. So we've got While 1 is less than or equal to 5, that passes. Print, please enter grade 1, colon, space, double quotes. We chomp and initialize $grade with the value that our user enters. We add the value of grade to our total. And remember, our total up here was initialized with the 0. So the first time we go through 0 plus equals 99 if I entered a 99 for the grade. Then counter plus plus. So we're incrementing our counter from 1 to 2. 2 is less than or equal to 5. Please enter grade 2, etc., until we hit 5. So 5 is less than or equal to 5. Please enter grade number 5. We enter the grade. We add it to the total. We increment that to 6. While 6 is less than or equal to 5 is obviously false. So the 6th time we break completely out of the loop, we don't do anything in gray. We come down and we generate the average. We have 5 inputs, so the total that we added up of the inputs divided by the number 5 gives us the average of our grade. And we're printing out our average just simply by interpolating it here. So let's check out and let's vim. I gotta move this up. Let's see, GB1. Yep, GB1. So there's our code. Looks a little messy because I copy pasted it, but that's okay. Again, we're declaring and initializing multiple variables up there on line 3. And our while loop is intact right here. And then we're going to get our average and the average of the grade. All right, so we're going to write and quit. We're going to Perl GB1. Now, remember we're talking percentages, right? So if we have 5 grades to enter, 4 of them are 100 and then there's 1 0, that should give us 80%. So let's try that. There's the first 100, the second 100, the third 100, the fourth 100, and 1 person didn't show up for class ever. So the average of the grades was 80. And again, the reason we get to the average of the grades was 80 was because in that very last line, we increment from 5 to 6. 6 breaks the while loop, and we get the average of grades was 80, which is the last lines of code that are in that particular program. Let's go ahead and grab the next slide. Oops. Let's talk here about Sentinel controlled loops. The Sentinel controlled loop, obviously we can't take that Scottish bagpiper and put him into our program. But what we can do is say, if I'm entering grades from 0 to 100, if I put a -1 in, that's outside of the range of grades. And that would probably be a good choice. If we were doing letter grades, A, B, C, D, or F, you could do the Z, the Z, or you could do a bang, or you could do Rumpelstiltskin, although making Rumpelstiltskin your Sentinel is kind of silly when you could get by with a 1-letter input. Let's see a couple of code examples of that here in a minute. Well, let's talk about priming the loop first. So what priming the loop is it is setting a variable that's inside of the loop. You know, while $grade is, or by $counter is less than or equal to 5, right? What we need to do is we need to make sure that $counter is from the very beginning less than or equal to 5, so it will go into the loop. If we set up a less than or equal to 5 condition, but $counter is 6 right off the beginning, it will never ever go into the loop. So priming the loop is actually prompting your user for a value and then sending that value into the loop the first time. So what we're going to do here is we're going to process the user's value, prime the loop again by asking for another number, and then it'll go through the same procedure we saw just a minute ago. So here's what we're going to do. We're going to declare my dollar input. And we're going to ask our user in 4 and 5 to please enter the word no. Chomp dollar input equals a diamond operator. We get just the no. We don't get the \n behind it. And then 6 is a while loop. Now this is a very rudimentary form of input validation. In other words, it is keeping your user where you want them until they give you what you want for the code, for the program. So we prime the number outside in line 4 and 5, or prime the loop outside in 4 and 5. If they give you the word no right off the bat, we go into the while loop. It says no, and boom, you're done. Okay. But if they give us anything but, if I type in the word you or yes, input does not equal no, and it traps us in the loop. And 7 and 8 reprime it. They say, hey, give me the word no. And then 8 says, give me the word no. 9 gives us the input. And from here, if no is equal to what our user input, it's now true. It's not false. You know, our input does equal no. We break out and say, thanks for finally typing no. And let's just try and run this puppy here. Devil. Wow, the lag is horrible. Horrible, horrible, horrible. You know what? I'm not going to wait around. I'm not going to try and look for that. So let's vim. Oh, wait a minute. This, no, it's not Gradebook. Just a minute. I got to remember what the devil we're talking about. Oh, Sentinel-1. So let's vim sent1.pl. And I'm going to go back over to WinSkip, and inside of here, Control R, and I've got to go find Sent1. There it is. I'm going to go back over here and grab a hold of this. Now remember, I'm doing this for expediency. You should really always be typing your code in. You'll eliminate repetition errors. Copy pasting is really a great way to get a million extra errors when you copy something that's incorrect, and it goes on and on and on every time you paste it. So it can be a real pain. So let's Perl sent1.pl. Please enter the word no. Yes. Ralphie, baby. If you are Mexican American or Spanish speaker, I don't know if Guantanamo is spelled correctly there, but it doesn't really matter. This is silly. Let me through your bloody wall. But if I type no, it gives me no. So you see it traps me in there until I give it what it expects. Now, the first time, please enter the word no. Yeah, okay. But it's very important for you at least to say, you know, hey, I was really looking for the word no. Please go ahead and enter that, or give them a range of values or something along those lines that you're looking for. Don't just let them do something silly like I did over and over and over again. Type a word in that I think is appropriate because you didn't tell me what you were looking for. because that'll just frustrate your user and you've lost a sale. Okay. Now, here is a numeric version of what we just did. Again, my dollar input is the same. Please enter a number between 50 and 150. Chunk dollar input equals a diamond operator. And then line 6 is our first chance to use our and, our or our not. Well, we've used the not a few times, but our and or our or. And in this case, while dollar input is less than 50 or dollar input is greater than 150, we're going to tell them we want them to do their input number in the range of 50 and 150. Why can't we use double ampersands? Why can't we say, I want this, my input to be less than 50 and greater than 150? Yeah, I'm sure most of you are screaming at the computer screen right now going, because you can't have a number lower than 50 and greater than 150 at the same time. Not with Earth mathematics, you can't. And I think our mathematics are pretty universal, at least as we understand it. So it has to be an or. You're giving them a chance to enter a number between 50 and 150. And if it's over or under those limits, it's asking you to do it all over again. 7 says, hey, you're dumb. 8 and 9, if you look, are exactly the same as lines 4 and 5. So let's see this run. Actually, I don't remember this being in there as well, so we're just going to do it that way. And let them sent to .pl. Save those. Again, I would prefer that you not copy paste. Whoops, I hit Alt-R, sorry about that. We need Control-R because it's better for you in the long run to do your typing. The more you type in the Vim editor, the better you're going to be at it. So we're going to save that, and I'm going to get this the heck out of Dodge. Get my picture out of the picture. So let's Perl sent to.pl. Give me a number between 50 and 151. Something else. 49. 149. Oops. I killed it. I forgot. I did a 143 up there. So let's do 49, but 149 will work. I was too happy. I absolutely forgot I hit 143. So, but you see that again traps us inside of that while loop until we get the number or a number within the range that your program needs. Again, it's silly, but there are many people out there that will try and break your code through your inputs. So we want to make that as smart as possible. All right, let's go back and look at some more of the slides here real quick. So we're going to revisit the gradebook here, but we're going to use a Sentinel value instead, so we can type as many different things in as we want. So here's our input loop, 6 to 11. 4 and 5 is our prime, or our primer, or primer. Print, please enter a grade or -1 to end. Primer, by the way, is like the books you learn to read on, or that old timers used to read on anyway. A primer is like when you're pushing the little suction cup on the side of your gasoline lawnmower to prime the carburetor, to put gas in the carburetor. This is more of a primer like the carburetor, the button for the carburetor, than it is a primer. But 4 and 5, as we see, are repeated as lines 9 and 10. So what we're doing here in the while loop aside from the priming the loop again, is while our grade is less, does not equal -1, total plus equals grade. So the grade that we just entered is going to go into our total. And then how many plus plus is the number of times that our user decided we were going to go through the loop. If we don't go through there at all, we are going to have 0, right? So then we say there are no grades to average. In other words, I didn't have anything to do because you didn't do anything in the code, or you didn't do anything in my program. Otherwise, we're going to give them the average of the grades. Yeah. So we start out at how many here with 0? Every time we go through the loop, we increment how many by 1. So 0 comes in, records the grade, and immediately we've got 1. The next time we have 2, the next time we have 3, etc., until we stop. So let's see if we got the grade book there. So gb2.pl. Nope. That was our no, actually. GB. Of course it's not. GB4 is probably what we want. So let's vim gb4.pl. That's our 50 and 150. Man, I need to take some of my own lessons here and rename things a little bit. So that's going to be it. So again, we declare and initialize our variables in multiples. We prime the loop by asking for a grade or a -1. While grade does not equal a -1, we go through every time we need to until our user enters a -1. If our user entered a -1 right off the beginning, that's when this code comes into play. So if we didn't change how many, we're not going to have anything to do. We didn't ever get a grade put in, so there are no grades to average. Otherwise, if we went in and did 1 to 1,000,000 different grades, we'll get the average by dividing the total by how many, the number of times we went through the loop. So let's run this now. So Perl gb5.pl. Enter grade or -1 data. If I enter -1, it says there were no grades to average. Let's do this again. Let's do the 100, 100, 100, 100. Whoops. Let's do 0 and then the -1. Now remember from the last time, this should be 80. And it is 80%. So our code works. And the while loop allows us to enter our grades as we want. Let's try and break it. Yeah. Let's see. One of the other things you could do is you could nest a loop in here so that if somebody tried to enter a grade higher than 125 or less than 0, that it wouldn't let them break out and go back to inputting grades until they put a valid grade in. So until they hit a number between 0 and 100. We might have that coming up in this slide set. Okay, we did this one, that's okay. Let's take a look at the for loop. Now, the for loop has 3 things: a start, a stop, a modification. We talked about those briefly as being consistent with all loops. The for loop, though, has a start condition, a stop condition, a modification condition. It's got 2 semicolons in there, which is a way that some people can kind of take a look and say, is this a valid for loop? at least at the level that you folks know. There are modifications on the for loop that can get pretty far out for some people, but basically we've got the for keyword, we've got the expression that we have there, and we've got whatever we want to execute inside the body if it's true. Looking at it this way is not very valuable because it doesn't have anything that we can think about, that we can kind of latch on and say, hey, I know what that's talking about. So the first loop that we showed you was counting from 1 to 15. So here's my starting condition. My starting condition is x is assigned the value of 1. And notice we've got the my there. And the my says, I'm creating this variable right here. So $x lives and dies within this for loop. It's born on line 3. It dies forever once we break out of it after line 5. And what I'm going to do is we're going to change this from a semicolon to a semicolon, a single quote to a double quote. All right. So let's see what we got over here. Isn't there a repetition? I thought I had a repetition. Well, so we're going to vim rep1.pl. Right, and quit. Now we've got the file there. We're going to go back here and let's try going from the top down this time. Come back here. I'm in the code, so Control R, and there's rep1. And we're going to paste it, save it, and get rid of it. And come back to vim and let's Perl rep1.pl. And look at that. Boom, 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 right down the line. Now, I want to show you what happens when we interpolate $x outside the loop. There we go. And that is, we change this into interpolation. Notice the instant I did that, $x became teal. And that teal means that we're going to be able to value inside of that variable and display it on the screen. But let's see what we get. We still get $x outside the loop, but notice, well, this is from the last time, but notice global symbol $x requires explicit package name. Did you forget to declare my $x at rep1.pl line 7? It's aborted due to compilation errors. So here's what the problem is. The problem is, again, it's called scope, and it's not the minty fresh mouthwash kind of scope. It's the scope of where does my $x, and in this case, $x lives and dies in the for loop. It can't break out and go into any other place after that last curly brace is done. But if we change the scope of where this variable lives, let's hit the insert key here and get a couple of them. Let's declare my $x equals 0. There's assign the value of 0. Now, let's run this and see what it does. You know what? So let's Perl rep1.pl. Now, notice what we have there. We expected probably 16, right? Because that's what we got on the while loop. But again, this is an issue of scope. What I did before prevented us from having a 0. But it's confusing as hell because now I have $x, one that lives outside of the for loop and one that lives inside of the for loop. The only way to make this work, if you want the $x down here somewhere, or if you want it available to you after the loop is done, is you declare it outside of the loop, and then you don't use the my command to declare another. So, colon, write and quit. Let's Perl it again. And now we've got the same output that we expected from our while loop experiments. Okay? So the for loop works about the same. It is just going to be in a different format. So we start off with $x being 1. We go through the loop. We increment it by 1. It becomes, well, 1 is less than or equal to 15. We say 1. We come back and x plus plus. So 1 becomes 2. 2 becomes 3. 3 becomes 4, etc., to 15. $x is 15. 15 is less than or equal to 15. We write 15 to the screen. We increment it by 1. It becomes 16. X is 16. 16 is not less than or equal to 15. So we immediately break out of that loop and say we cannot access 16 outside the loop. Cool. That is a very, very common structure inside of coding, and it's something that you should become very familiar with. Now, just like a while loop, we can do the same thing with x minus minus. And unless we go into that whole mess we just dealt with in plus plus, once again, you're not going to be able to access that $x outside the loop because it doesn't live outside the loop. I'm not going to do this one. This is what, 6 lines of code. Y'all can do this on your own. And that will basically, I think, be a pretty good exercise for you. Now, here is another example for us. Whoops. This is a way that you can make sure that your user gives you a set of numbers, or a range of numbers rather, that, well, let's get it in here first and then let me talk about it. So let's vim range1.pl quit. Come up here and control R again. There's my range 1. And there we go. We're going to save that. So let's vim range 1 again. What the heck? Oh, there we are. So we're entering a starting number. We want a range like from 1 to 100. Please enter an ending number that is more than, if I put a 1 in there, it's more than 1. We chomp that $end, and if $end is less than or equal to start, we're going to make them go through the loop forever until they give us the right number. Then we're going to use a for loop to give us the even numbers between where we start and where we end. So let me hang on. Sorry about that. Somebody decided to spray some raid on one of the spikers outside my door. So I had to set up a little bit of ventilation here. Anyway, what we're doing here is we're setting up a range of numbers, and then we're going to use math if x mod 2 is 0 to give us all the even numbers out to the screen between the two values that our user enters. Escape, write, and quit. I was right. I accidentally put a number inside of my shebang line. Enter a starting number of 50. Enter an ending number more than 50, 25. Minus 100. Let's try 99. And from 50 to 99, the only even numbers end in 98. And if I scroll back up, you'll see we start at 50. So pretty cool. It's an easy way. I can think of all kinds of different ways that we can utilize that kind of stuff in our programs, especially in games and things that use random numbers and so forth. So where am I at here? Let's minimize that. Let's come back here. And what do we got next? All right, here we're going to do data validation for our grades. Remember I said that this was okay, except somebody could enter 125 for a grade that's from 0 to 100. So again, total, counter, grade, average, how many? We've only got 4 values here. So total is 0, counter is 1, grade and average are 0. How many will be left as undefined? How many grades should we process? Again, we're going to do the same thing we did in that last by saying this is how far we're going to go. We're asking our user, they put that into how many, and we're using how many in a different way here. So it's not quite the same as we had before, but it's pretty close. While dollar how many is less than or equal to 0, because we can't enter a minus 25 grades. We're going to force them to give us something positive. Well, we'll consider 0 to be positive in this case. And then it just keeps going on until we get something above 0. Now, here we've got a for loop. And inside of the for loop, we've got a while loop. So we're going to go through this how many times, whatever our user enters in. We're going to ask them for a grade. We're going to chomp it. And now notice the while loop. While dollar grade is less than 0 or dollar grade is greater than 100, please enter the grade again. So we can get stuck on the internal loop a million times and then get stuck on the outside loop while we're trying to enter our numbers too, depending on how you write the code, of course. Once we, in the for loop, the last thing we do after the while loop that's inside of it is total plus equals grade. And then the for loop ends at line 18. That's one of the reasons that I prefer to have it like this. And I prefer to have my curly brace there like that. Well, oh, come on. I did not ask. There we go. Like that. Because I can tell quite easily now that this and this are part of the same for loop. I can tell quite easily now that this curly brace and this one are part of the same while loop. So it's easier, at least for me, to see things that way. And then again down here, let me get rid of this. Average is going to be our total, because we're adding every grade we put into dollar total, divided by the number of times we put something in. And that's our how many that we ask our user for up here. And then we're going to give the average of the grades just by printing out with interpolation the value that we got in the equation in line 20. Again, I don't remember if I've got this or not, so we're just going to put it in new the way we've been doing. Not Control V and pasting the old, but Control C and copying. And I want to vim rep2.pl and write and quit. Now here, and again, we got to Control R to refresh, or right click and refresh. Did I save that? I did save Rep 2. So let's try this again. There we go. I must not have had the Control key held down far enough or something. So paste. I'm going to save that. We're going to kill it. I think we got everything okay. So let's Perl rep2.pl. How many grades should we process? Let's say -10. How many grades should we process? Let's say 0. Oh, because I took the equal out. Okay. 1 grade. Intergrade 1 is 100. The average of the grades was 100. So the total is 100 divided by 1. 100 divided by 1 is 100, of course. Let's try 5. And again, I'm going to do the 4 100s and the 0. And the average of the grades was 80. So you see, we've got this same grade book, but we're making it smarter and easier to use with larger numbers of students in our program. Now, let's see what else we're going to do up here tonight. I've got to move this silly thing again. That was it. Our next step is going to be arrays. So we'll see what we do on those here in a bit. All right, I'm going to stop our sharing here, and we'll put another video out with arrays soon. So we'll see you guys next time.